Okay, now we're going to learn how to solve linear inequalities. An inequality is mostly like an equal sign when you're solving something. There's just one time that you could have a difference. When you're adding or subtracting, inequalities, equal signs, you treat them the same. But when you multiply or divide, you have to be careful. If you multiply or divide both sides of an inequality by a negative sign, you have to flip the inequality. Okay? Now, that's annoying to have to remember. So I have a policy that I try to avoid it as much as possible. This leads us to warning number 7. To avoid having to flip the inequality, if you can, make the coefficient of x positive and then you don't have to worry about it. Okay? So, let's start with this example. Just like if there was an equal to sign, I want to solve for x. So the first step is to get all the x's on one side. Now if it were an equal to sign, I wouldn't care which side. But it's an inequality. So I could say, let's subtract 3x from both sides. But then I'd end up with a negative 5x over here, and I don't like negatives in front of x's. So instead, I'm going to add 2x to both sides. Then add that 5. And now I can divide by that 5, and I'm not going to have any trouble where I have to remember to flip the inequality. All right, now these two are what are called compound inequalities. A compound inequality is two or more inequalities joined by either the word and or the word or. Now I have to warn you that in math, these words don't mean exactly the same thing as they mean in English. And basically does. And means that I need this one and this one to happen at the same time. That makes sense. In English, if I say I want apples and oranges, I want both to end up on my plate. Okay. And or means something different though. If I were to go to a waiter and say I would like apples or oranges, they'd probably pick whichever one is most convenient, dump it on my plate, and I'd end up with the plate with only one or the other, but not both. But in math, we allow the possibility that or could mean both. Okay. So when I have two inequalities joined by an or, this one could be true, or that one could be true, or both of them could actually be true. Now, how do I solve them? Okay. It would be easier if I could solve just one thing and not have to worry about two separate things. And the beauty of an and is that you can put them together. So you notice both have a 2x plus 5. So it's going to go in the middle. This one says the 2x plus 5 is less than or equal to 7. This one says the 2x plus 5 is greater than negative 3. And there's absolutely no reason to have to write the 2x plus 5 twice when it can just sit in the middle of the other two. Now, I solve these like I would an equal to, only instead of doing it to both sides, I have to do it to all three pieces. So first I'm going to subtract 5 from everything. Then I'm going to divide 2 through everything. And I get an answer that x must be bigger than negative 4 and less than or equal to 1. So all the numbers between negative 4 and 1. Now, an or, if I tried that same trick, they both have the 2x minus 5. This says it's less than or equal to negative 7. This says it's greater than 1. And you say, well, why doesn't that work? Well, ignore the middleman for a minute. This says that 1 is less than negative 7. I don't know about you, but I have a problem with that statement. So we cannot combine them, and if we try to, we get nonsense. So these ones have to be solved separately. So I add 5 to both sides, and I divide by 2. I'm going to do the same steps over here. I'm going to add 5 to both sides, and divide by 3. And my answer is x is less than or equal to negative 1, or x is greater than 3. Okay. All right, now we're going to come over here and we're going to talk about absolute value inequalities. Now, when you combine an absolute value and an inequality, there's two ways that it could happen. It could be an absolute value is less than a number, or an absolute value is greater than a number. And these are treated a little bit differently. As we learned when we were solving absolute value equations, there's always two answers, the plus and the minus one. When it's a less than, this turns into a triple inequality, just like the and statement did. Here's the negative a, less thans, just like that one was, and the x is in the middle. Okay, if I try that with the greater than, I get that negative a is greater than a. That doesn't make very much sense. So I get nonsense, it doesn't work. Instead, I have to separate them into two inequalities with an or in the middle. Okay, so this one turns into an and with a negative a on the other side. This one turns into an or with a negative a on the other side. Okay. All right, so our first example is a less than. So I'm able to write it as one inequality that I then can solve simultaneously. First by subtracting 2 from everything in sight, and then by dividing by 3. That's my solution. My last one is a greater than, so even if I were to try to write it as a single inequality, I would get nonsense. So I can kind of pretend like I'm writing it as a single inequality, using the same setup where I keep the inequality sign, and I put negative the number on this side, only I doubled the middle. I solve each one separately. Now, remember, I don't like the fact that there's a negative in front of that 2. So I'm going to add the 2x to both sides. I'm going to add 1 and divide by 2. Here I'm going to subtract 1 and divide by 2. So I end up with x is greater than or equal to 3, or x is less than or equal to 2.